right screen now. Awesome. Oh, thank you to whoever dropped that. All right, today we're going to be talking about Aurorasaurus. We are talking about Aurorasaurus because it's a NASA project aimed at predicting the visibility of auroras by crowdsourcing pictures from you all of these beautiful northern and southern lights. We'll hear from the founder, who we'll introduce in a moment here, to learn about what auroras are, where and when to see them, exactly how we can get involved and help out. And we'll hear from a photographer who we've met, Hugo, right here, and we will introduce him as well again to talk about how to take beautiful photos of auroras and make them research grade pictures to help the scientists out even more. So as we get started here, I'm going to go ahead and let those two introduce themselves. So Dr. Liz MacDonald, would you like to introduce yourself?
Hi, good day, everyone. I'm excited to be here. I work at NASA Goddard Space Flight Center in the area of heliophysics, which is kind of how the sun touches everything and creates the aurora, which I've been studying for quite a while. And I founded Aurorasaurus about 10 years ago, and it's been just really exciting to be able to share and utilize these wonderful photos for science, as we will talk more about. And I'm very excited to share the webinar today with Hugo Sanchez, one of our very dedicated volunteers.
Thanks, Liz. Hugo, do you want to introduce yourself?
Hi, my name is Hugo Sanchez. I'm a citizen scientist for Aurorasaurus, and I'm a photographer. And I live in Edmonton, Alberta, Canada, cold place, and that's where we get auroras usually, where it's cold. It's not the colder the better, but yeah, here we have lots of cold weathers and beautiful auroras. I have been taking photos of the aurora almost as much as Liz has been studying. I've been taking photos for 10 years, I think, a little bit more than 10 years. So, and like, it always amazed me of the beauty. And if I can go every day, I would go every day. And that's why I try to take as many photos and as much information for aurora, so we can predict aurora better, or NASA can predict aurora better.
Excellent. Thanks so much, Hugo. Laura, I apologize. Would you mind just giving a brief introduction to yourself so we know who you are?
Oh, sure. Sorry about that. Hi, I'm Laura. I am the project manager for Aurorasaurus, and I am just sort of sitting in and helping out as needed today.
Excellent. Awesome. Happy to have you on board. All righty. Okay. I will have you, our two guests, move forward at this, but I just wanted to make sure that we understood how to access Aurorasaurus on SciStarter. You can look up Aurorasaurus and the word SciStarter and it'll come up on Google, but on SciStarter, this is the official link that you can look up. And when you hit the visit button, it'll send you onto that page. And we'll do a quick tour of that page as well when we get to that part at the end of the presentation. Awesome. All right, I will let you move forward.
Great, thank you so much, Emma. We have Hugo here.
Oh, could you say that one more time, Liz? I think it's cutting out.
Sorry. We thought we would start by asking each other a few questions about auroras, and they all feature Hugo's photos and some of the wonderful stories there. So Hugo, do you want to tell us a little more about how you got started taking aurora photos and the journey?
Well, it is kind of comical because the first time I took pictures of the aurora, I was actually looking to take photos of the meteor shower. So I remember going at night, and I didn't have experience. Even for like meteors, I had no experience, but I went there at night. And then I'm like waiting, and then the meteors are like going everywhere, but I cannot take any photos because that's how it is to take photos of meteors. Anyway, so I'm like looking north, and then all of a sudden I see the sky started moving on the north side. I'm like, what's that, right? I had no clue what it was. So and then I I didn't know how to take a picture of that Northern Lights. I didn't know what it was. I know it's Aurora because I can tell it's the sky, it's green and it's moving. So I said, well, I'm just gonna take photos whichever way I want. And if you look at the photo here, you see like the ground is lit. So what happens is because I didn't have any idea how to take photos, I put my camera had a flash, and I even put the flash so I would take a photo. And yeah, I took a few photos with 20 photos or so, and I was like really excited and surprised at the same time that I got to see the Aurora, took pictures for the first time, and that was the beginning of this beautiful journey. And after that, I started looking, where do I find them? How do I find them? How do I take pictures? Where do I go? When do I go? And all those, I started doing researches about it, and that led to what I am right now. And as you can tell, there's two in the screen. There's like, let's say amateur and professional, right? So that's a two big different. So I went from the top photo to the bottom photo there. So he has been amazing, and I'm glad that now I can help also science with my photography. But being from the first time that I didn't know anything about it to now I know. I can't say I know too much, but I know a little bit more. And so I can help the community with the Aurora. So that makes me happy that I am part of these. And then I became citizen scientist, I guess, with that photo that I did not to take it.
Yeah, thank you so much, Hugo. This photo from Alaska is amazing. And I know you had a very special trip out there to Alaska and have even been featured. A lot of your life story has been featured various places, and that's been really very cool as well. So, auroras are, of course, not just the science and the Western science, especially that I tend to talk about mostly, but they have a lot of deep spiritual meaning to many, many different people. Do you want to say any more about the Alaska photo, or should we look at some more?
Well, I can say a little bit. So what it is I do have a connection. If I can be talking here for hours, but I only have like a limited time anyway. So what happens is like my story between the Aurora and the and myself. There is a deep connection, and also my son. My story is pretty sad, but at the same time, it's beautiful, and that connected me. The Aurora connects me to my son, who passed away about like 6 years ago, and he was 10 years old. He was born with like cerebral palsy, and in indigenous beliefs, they believe that Aurora is ancestors dancing in the sky. And in that, I had that in mind until I remember one night I was in Elk Island. It's like 30 minutes away from the city. So I was being there, I was taking pictures. And I remember like, because when you take photos, you usually take photos like this 45-degree angle. And I remember taking pictures of the Aurora, like put my camera on the ground like this. And after taking a photo of the Aurora, I look at my camera, and on the back of the camera, it was an angel. And to me, I just went on my knees and cried because my angel, it's my son Emilio. And at that point, and then I was like, yes, indeed, the Aurora, it's ancestors dancing in the sky. Because at that point, that was my son dancing for me. And since then, that became my story. And I've been telling people my story in a magazine, outside magazine, heard about it, and they spoke to me, and I told them everything that I'm sort of telling you right now. And they decided to write a story about me and my son Emilio on the Northern Lights. So they took me to Alaska to chase the Aurora and to write the story. And that photo is one of the photos that is in the magazine. So we're in the middle of nowhere, and it was really cold. But then Alaska, it's another level, Alaska, Norway, and all those places. So that's where I took that beautiful photo.
Thank you so much, Hugo, for sharing both your story and your photos. They are so meaningful and appreciated. On the next slide, we see some photos. I think these are from Edmonton, if I'm not mistaken,
Yes.
and from a larger event. So you can see more colors in larger events. The Aurora is not always this spectacular in Edmonton. It's usually more spectacular the farther north you go. But these are just some stunning examples of Aurora. On the right-hand side, you're looking straight up at the Aurora. And so it appears to kind of converge to a point. And also, so it must have been very, very active to get all of these different colors. That means there's many, many particles. So some of the colors that are caused when particles from space are hitting the upper atmosphere. There's a lot of different colors that can come out, but they're normally pretty dim. But when you have a larger storm, such as driven by a larger explosion from the sun, you really can have very bright and vivid colors. Do you want to say anything else about these photos, Hugo? These are great. I think you're muted.
Sorry, we don't always have these beautiful colors. This night, I think we had a KP8, and we have a scale from 0 to 9. And that night it was like a KP8, and it was just an amazing. It was all night long that we had the show, and I was driving everywhere because I had to get out of the city. And then I kept driving closer to my house because I went an hour away. And then I'm going like driving back, because at the same time I have to go back to work the next day. So I'm going back, and this is like half an hour away from Edmonton. That's where I live. And we that night, like she says, we don't always have these beautiful colors. It's usually we see more green than anything. But when we have like major storms, that's when we start getting all these like other colors, reds and yellows and blues and purples. So being under these aurora is so magical. It's so amazing. It's just, just telling you the story, I get the chills. And trust me, I have seen like hundreds and hundreds of storms, but one like this is like, wish we had those storms like here all the time. Unfortunately, we don't. But when we have it, we enjoy them.
Our Aurorasaurus project has been very fortunate to collaborate with people across the world. And especially, we have an especially close relationship with folks in Alberta. Hugo is in the center, the capital of Alberta. Many of the Canadian cities, central and southern Canadian cities, you can go about half an hour outside the city and be able to see aurora that on occasion can be this spectacular. And it can also be this spectacular in the northern US states, or more rarely into further south in the US, further away from the poles. I saw a question flash by about the colors, and basically the most predominant color is green, and that's caused by electrons from space hitting the oxygen at the very edge of space, about 60 miles or 100 kilometers up. I have kind of a diagram of how you get different colors as well coming up in a few slides. But we're going to look at a couple more of Hugo's pictures and then talk a little more about Aurorasaurus. So Aurorasaurus and citizen scientists from Alberta and Saskatchewan and across the US also have been, and across the world really, have been noticing a new and less not well-known, different kind of aurora in the sky, unusual kind of aurora. And a couple of years ago, this became a really big discovery for our projects, and is very exciting both to the public and the scientists. It is a new or almost new kind of aurora called Steve. So it's now called Steve, and it's something that can be seen especially well from Canada, southern Canada. When the aurora is far to the north, there can be Steve looking like kind of a plain contrail cutting across the sky east to west. And when we started our Aurorasaurus projects in 2014, people started talking about something they were seeing that looked like this, that didn't have a scientific explanation. And now we actually have some satellite observations, and we know that this is formed in a different way than the usual aurora. It runs from east to west, and so it's a really strong flow of particles in the upper atmosphere. And people keep collecting photos of Steve. It's been just a wonderful collaboration of citizen science. And these are some of Hugo's first pictures of Steve. So everyone has a different story of how they met Steve. And Hugo, do you want to say more about these first pictures of yours?
Yes, I remember I never seen Steve because I live like in the center part of Alberta, like the southern part. That's the one that sees more aurora. We see less, so I'm always like trying to find Steve. It's like, oh, I can't find it. I cannot find it. Always looking around. And I remember one night I'm driving, since there was no aurora. The aurora was like pretty dim. So I said, I'm going to go find a church and take some photos. So I'm driving and my car has a sunroof. So I look up and it's like, oh my God, I saw Steve. I saw this line, right? So I immediately know that I never seen Steve, but I know that's Steve. So I stopped my car and this is in the middle of the road, but it's a highway. Nobody drives by. It's one of those dead roads that people don't really go there, small town. So I park on the side of the road and I started taking these pictures, but it only gave me time to set up my tripod, put myself there. I took pictures. So 1 minute I was there, I took like 5 pictures, and all of a sudden it just disappeared into thin air. So Steve was gone. But it was really exciting for me because I'd never seen it before. So I was in my car, I went in my car, I'm looking at the photos, I'm like yelling and screaming, woohoo, like so excited. It was really, that's a pretty exciting photo. Every time I see it, I get really excited because that was my first time I saw Steve. And it gets better, trust me.
That's so great.
It's not like this dim, it gets better, so.
Hugo told me about this first sighting of Steve the other day, and I got excited because I haven't heard of a story of someone seeing Steve for such a short amount of time. So we still don't know how long Steve lasts. Usually it's on the order of 20 minutes or so, but this really illustrates how agile citizen scientists are and how people deliberately going out and keeping an eye out for unusual features. So you can see how this project has some parallels to other more biological projects where you might see a unique species of bird or penguin or something like that. And it helps us, every sighting of Steve helps us to understand more about how often it occurs, and the whole space system. How is this occurring? It's a fairly rare thing and has been previously overlooked, but every kind of piece of understanding the larger space system helps us to get to the point of predictability where we can understand the auroral system. And the aurora actually has some have some effects on technology. It's basically large electrified currents up in space. And so it can actually affect our technologies on satellites as well as on the ground. So we want to understand all pieces of this system, and people are really valuable to doing that as well. Let's look at the next picture, which includes, I will be pulling over very soon, so sorry for difficulty with my audio, sorry. This picture includes kind of the typical color arrangement where you have green on the bottom edge of the aurora and then some red up above it. Both of those are actually caused by oxygen in the upper atmosphere. And then the picture on the right has, I think this might have been a pulsating type of aurora.
Yes, it is.
And many, a little bit of pink below the main kind of fluorescent green, as well as some purple up high. And Hugo was asking me about why some pulsating aurora that turns on and off rapidly tends to have a little more, sometimes it can have this pink on the lower border. And that is a great question because the pink actually tells us that the particles coming in are more energetic than usual, which means that they basically hit the upper atmosphere and they slow down with each little collision. So if they come in with more energy, they can actually collide further south and lower in altitude, and they can get through that oxygen layer and hit a little bit of a different particle called nitrogen that's below that, and that can cause the pink. Sorry, Hugo, do you want to tell us anything more about these photos? Did that make sense?
Yes, it does. It does. Yes, it does. Well, I can just talk about quickly about these the two photos. The one on top, that's usually looks like a kind of sort of rainbow aurora. That's also, it's not usual that you see pretty much like a rainbow. It's usually the aurora is like, it's different. So that night it was quite different, which was like great to see, because aurora is also always different. Aurora is like a snowflake. It's never going to be the same. You can go to the same spot all the time. The aurora is going to be in the same place where you go, usually. Depends where you are. You have to be facing north in Edmonton, right? So in Alaska, they go everywhere. They go on top of the sky. So, but in this case, it was great to see a different kind of aurora. And the one on the bottom, it's, because this is really different thing to see. The aurora is different. The aurora is like, it's called pulsating because the aurora can go. It's always like going, it's moving. And that's why I was asking her about the colors, because at the end of every pulsating, that every pulse it gets, you get these blues or you get these oranges, or not oranges, but pinks. So it's like, it's always at the tip, it's like, you see it like blowing, going. And it's really interesting to see pulsating aurora.
We had a quick question in the chat that I wanted to make sure we heard. Someone's daughter asked if it was possible, maybe not now, but in the future, is it possible to capture an aurora in a bottle somehow? Charged particles.
That's a great question. There is something called...
Oh no.
It's okay. What she's saying is there's something called a planetarella.
Planetarella.
Here we go.
Oh,
Go ahead, Laura. If you, I'm pulling over and my signal's getting worse, so apologies again.
That is totally okay.
Do you want to talk about that for a sec?
Yeah, sure. Just very briefly, I posted a video in the chat. There's a device that was used by early Aurora scientist Christian Birkeland called a planetarella that mimics the physics of the sun and the earth in creating auroras. And it's in this, not quite a bottle, but it's in a container, and it creates little tiny auroras around a little tiny planet Earth. And it's pretty wonderful. So I'd recommend watching the video.
Museums that have those around. Laura, maybe we can come back to that. And actually, I might need you to cover the next few slides if you're able to do that.
Sure, happy to. So basically, one of the questions that we get a lot is, what is the aurora? And the aurora is both in the northern hemisphere and the southern hemisphere twinned because of the physics that make it work. The northern lights are called the aurora borealis. The southern lights are called the aurora australis. It's made by this relationship between the sun and the earth. And it happens way, way up in the Earth's atmosphere, miles and miles and miles above mountains and airplanes, and even up into the area of the upper atmosphere where the International Space Station moves. You can also get auroras on any planet with a magnetic field. You can get the kind of auroras that we have on Earth. So Jupiter is one of my favorites because they have some really great photos of that. You can move to the next slide. So what causes the aurora is really, really interesting and complicated. And I will say straight out, I am not a scientist. I'm a museum educator. So I had to learn this. And one of the things that I learned is there's always a little star that says, well, wait, there's more after every explanation of aurora. But very simply, the sun sends what we call the solar wind, full of particles and magnetic fields towards the Earth. And it's actually moving out from the sun in all directions at all times. But when it comes towards the Earth, the energy and the magnetic fields can hook up with ours. And through this complex process, they get accelerated towards the poles on the night side of the planet, the side away from the sun. And they come down through the upper atmosphere. And as Liz mentioned earlier, it's almost like a Plinko game where as they're coming down, they ricochet off of different atoms and molecules in the Earth's upper atmosphere, giving them extra energy, which we call exciting them, which then those atoms and molecules, to get back to normal, have to give off as light. And each gas and or each atom or molecule gives off a different color. So oxygen gives off red or green, and nitrogen gives off blue or pink. So one of my favorite things about the aurora is that when we look at it and we see those colors, they tell us how high up the aurora is based on the layer of oxygen or nitrogen that we know is there. And they tell us what exactly it's made of, which is really, really cool. You can do the next slide. And I went over this a little bit. So you get these different colors, and sometimes you'll see auroras that are yellow or more of a cyan color. And that can also be from the light mixing, and light mixes differently than paint. So when you get red and green mixed together in those oxygen colors, you might see some yellow as well. But again, it's this wonderful detective mystery where we get to see a lot of information just from looking at the colors of photos like Hugo's. Next slide. There's also different types of aurora. The ones that we think of photographing and some of those amazing photos that Hugo had are what we call discrete arcs, where we get these really clear shapes. But you can also see it almost like a haze on the horizon, which we call a diffuse glow. And we talked a little bit earlier about pulsating patches, and here's a wonderful GIF of pulsating patches. And you can see that they're literally blinking, almost like an auroral disco. And then we have a great picture of Steve as well. And we talked a little bit about how Steve is really special as far as aurora related phenomena goes. Next slide. Liz, do you and Hugo want to take over here? Actually, Hugo, do you want to talk a little bit about what you need to do to see the aurora? It's you are the expert there. I've only seen it 3 times.
All right. Well, I guess, let me see. Okay, because what happens to me when it comes to the aurora, you always need to plan. You need planning. People say like, well, I'm just gonna go out and take pictures. No, because aurora has its own mind, and it comes out. It doesn't come out all the time. It comes out sometimes if you live in Alaska. So if you live in Alaska, there is an oval, aurora oval, which is like really high up, like on Earth. And those guys, which is Fairbanks and Yellowknife and Churchill and Trump, so places like that, they see it every single night in wintertime. They go from the fall to spring, because and then they have fall, they have like winter, and they have like spring. So they see it pretty much every single night. But then as you're getting like lower and lower, there's less chances to see the aurora. So like the further south that you live, so you need planning when it comes to the aurora, because so, and then also you need apps. Apps are important. We have I don't know if somebody can write it, but the best app is Space Weather Live altogether. That's the best app. That's more accurate, and they send you alerts, and they tell you when the aurora is gonna come out. They give you like 3 days heads up, so then you can plan to go. Then you can plan to. So you also need apps for the weather, because that's important. You need clear skies, otherwise you won't see anything, even if there's a big aurora. And like I said, that's the 2 important things that you always need. Otherwise, if you just go every night, just drive. People say like drive. You need to drive out of the city. Also, you need to drive out of the city. Because the light pollution kind of blocks the light from the strength from the northern lights. So the closer you are from light pollution, the less you see it. So that's why it is recommended to get out of the city so you can see it. And in Edmonton, so we always usually go north, because you always have to look north. And because that's where the aurora comes from, northeast and northwest. And also we go east. That way you go east or west, and then you look north. We don't always go south, because the city is, so you always need to find the best way to, the best spot where you can see better when it's darker. Usually, provincial parks, those are the best places. Dark spaces, dark skies, preserves. That's where you need to go. That way you see more aurora. So, but yes, planning, get out of the city and check the weather so you can see. That's when you see the aurora. And also, like I said, the app is really important, because that's where you can find them. And the further north you go, the better chances you have. So the best chances you have, like places like I said, Fairbanks, Churchill, and those are like really wonderful places to go. But also they're like cold places. But that's the best way. Those are the best places to go. you need to be going to the cold weather, just dress for the weather. So
I love that. And as you're saying, dress for the weather, I know that we had a video of Hugo, in fact, gearing up for the weather. Emma, could you run that for us?
Yes, I can. Let's see. Is it switching screens for you?
Yes, it is.
Yay. All right. I played it for a couple of seconds, so we're like a second in, but the process continues.
It's always amazing to me, Hugo, how many layers you need to put on there. I'm based in Maryland, and right now it's in the upper 80s Fahrenheit. And so I can't even imagine, what temperatures do you get to when you're chasing?
well, -20, -30.
Sorry.
Very cold. I
Oh,
can't even, no wonder you need so many layers. And that looks like a special coat that you're putting on last, is it? Kind of
Well, yeah.
lining.
Well, everything is, it's if you can find, see, it's like those long johns or those underpants. Those are special pants. I mean, because those are like, they keep you warm. They have like the new technology. Everything has new technology, right?
Sure.
But it's the same as the jacket. It has all that new, because you don't want to put a thick parka, because then it's you're carrying these things, you're carrying a bag, you're carrying cameras. So the less you need to have flexibility. That's why if you see two, I have two pair of gloves. It's not just one, but two, because you don't want to be touching when it's minus cold. This gets cold, everything gets cold, it even freezes. So you don't want to be touching with your fingers.
Oh my gosh.
Amazing the camera still works.
But I believe you can also,
cameras are really good. Cameras are really good. So
yeah, you can also see, just in case anybody's worried, you can also see aurora at lower latitudes. And we had a question about where the aurora is seen the most. And as Hugo said, there is that sort of auroral oval around the poles. But when it gets extra energy, when the Earth gets extra energy from the sun, during like what's called a coronal mass ejection, which is the sun sneezes a whole bunch of particles at us, and magnetic fields, the auroral oval can push south in the northern hemisphere and north in the southern hemisphere towards the equator. So you can see it in places like North Dakota and Iceland, and I've seen it when it's above freezing, which was great as well. So there are a lot of really wonderful places that you can see aurora. But I think one of the most important points is that the aurora isn't something you can plan for in the way that you can plan for a comet.
right.
If you're going to photograph a comet, you know exactly where it's going to be, you know exactly when it's going to be, but auroras are always a gamble. Everything can look great and it can turn out poorly, and everything can look poorly and it can turn out great. And Hugo, what does that feel like?
Well, like aurora can be frustrating, because like she says, we go, the up says, oh my God, it's gonna be like really high KP6s, right? KP6, oh, you can't go wrong. KP7, you can't go wrong. It's gonna be beautiful. It's gonna be like dancing all over the sky and all that. You're excited, so you go there. You even drive before, so you get there. It's like you can hear everything.
That's amazing.
Like the frogs, the crickets, everything's like, where did Aurora go? It's like, yeah, waiting. And then another thing is like, you are over there and you're like, okay, just pretty soon, like half an hour, another half an hour. And now it's like 1 o'clock, it's 2 o'clock. It's like, okay, no, I'm gonna wait one more time, like, a little bit more. And then 3 o'clock, it's like, you give up. It's like, you go sad. And then the next day, the Aurora up says, there's going to be Aurora tonight. You're like, woohoo, you get excited and you just go again. And yeah, it can be frustrating, but if you really love the Aurora, you're always going to get excited. That's part of the job. So that's part of the chasing. Sometimes you come out empty-handed. I've been going there sometimes. It's like, she didn't show you the pictures, but one time there was no aurora activity, zero. And I went out and Steve came out Steve, and he was glorious. He was amazing.
Wow.
He was big. So sometimes, if the sky is clear, might as well gamble and go at it. And who knows, you might find a really beautiful show. So
Thank you. And Hugo, Trevor wants to know, are there Aurora viewing parties similar to star parties since the Aurora can be so fickle?
what's that?
Trevor wants to know if there are groups that go out Aurora chasing together, like a star party.
Yes, like depends on, I'm pretty sure like every city has an Aurora group, especially like in the northern you live. They gotta be groups. Like we have Aurora chasers. And what we do over there is like there's people from all over the province, and we tell each other, we go there. Today there's a thread because we know there's Aurora. And we just put photos or data. We say like, it's out in Edmonton, it's out in Calgary, it's out in Fort Montgomery, and then all these people go. And in the party, you have to get together with your friends and talk to your friends, or in the group say like, who wants to go such a place? For us, it's Elk Island Park. We go there like by hundreds of people there. Like, we even have a problem with too many cars, too many lights, but that's a different story. But there is a party, people go. Depends where you live. So.
And that's a really great point. Aurora safety is very important. As with any kind of night sky activity, you want to be aware of your surroundings. You want to be in a place that is safe and legal to be in the middle of the night. I also noticed that, thanks, Trevor. I also noticed that Liz is back on, so just wanted to touch base with her. Liz, we've been talking a little bit about how to see the Aurora. Liz, you are muted. Okay, well, we figured that out. Can we go to the next slide?
Yes, and one quick thing, since we were talking about where to find them, there was a possible sighting of Aurora in Tucson, Arizona, south of where I am. I was curious if either of you knew how that had happened.
Yes, absolutely. So when we talk about the Aurora Oval, and I'm a little sad with myself that I didn't actually put a picture of the Aurora Oval in this presentation. It is an oval around the North and South poles. It's this big kind of donut shape, and it usually sits on top of places like Churchill, Manitoba, and Fairbanks, Alaska, that Hugo was talking about getting auroras every day. And you can see some of where it is right now on Aurorasaurus, exactly. So it's this kind of almost a donut shape around the Earth. And when the sun provides it with more energy, it can push further towards the equator. So what happened in March and April was this incredible event, because the sun is becoming more active right now. It's heading towards what we call solar maximum. The sun sent so much energy into the auroral oval that it pushed it far enough down that we could see aurora from my latitude at Washington, D.C. We could see aurora in Arizona. There were sightings in Texas. There were sightings in North Carolina. It was incredible. And one of the great things is that's more and more likely to happen as the sun becomes more active. So I would definitely recommend joining some of these aurora groups on social media, because they will definitely let you know when stuff is happening. And you can also sign up for an account on Aurorasaurus. And if people around you are reporting seeing aurora, you will get a notification that the aurora is being sighted near you. And while we're on here, Emma, do you want to just demo really quickly how Aurorasaurus works?
Sure.
Can you guys hear me again?
Oh, there's
hey.
You don't need me, but I am back. Just
You're
on
good.
the audio. I'll let you go ahead and demo Aurorasaurus, but I wanted to thank everybody for bearing with me, and also the team effort here is fantastic. Thank you all.
Oh, no worries, Liz. I've got a big thunderstorm over me right now, so hopefully we don't just land Hugo with it all. But if you see aurora, or even if you don't, because no reports are just as helpful, go up to the top of the page and click whether you saw it. Did you see the aurora? Yes or no? It'll ask you just some very basic questions. The most important questions are your location and the time. And you can add a little bit of description. You can add some additional comments. We love details, any kind of details you want to provide, and the additional comments are really helpful to scientists. If you make a yes report, you can add a photo. And it's important that photos come with really, really good timestamps, and that helps scientists coordinate different photos across one another to get a good feel for what might have been happening in multiple dimensions, so they can calculate height and they can look at change over time, things like that. And then all you have to do is report this observation and you are good to go. It'll show up on the map and we'll populate the map. And during big storms especially, it's really fun because if you go on there, you'll see as the Earth turns underneath the aurora, you'll see the reports just start to move westward and westward and westward, which is really, really fun. If you want to go back to the slide, we have a couple of other resources as well on the page. Under Learn, you can get some really useful beginner level descriptions of how the aurora works. And as always, there's always an asterisk and it's always a little more complicated, but growing your understanding, as I have been doing with Dr. Liz, who's incredibly patient with my little math phobic self over the last 4 years, is an amazing process, and we just keep learning and learning. We also have a blog where we go into detail on certain topics. There you see a camera, an Aurora camera that broadcasts and live streams Aurora from North Dakota, that was built by Vincent Ledvina, who is actually on the call right now. Hi, Vince. In collaboration with Aurorasaurus, the University of North Dakota, and Live Aurora Network. So we go into details on how that was made. He has schematics on there, all kinds of cool stuff. As you can tell, we're all big science nerds, and we just love getting excited about this stuff with people. Next slide, please.
I don't know if we're running out of time, but we definitely want to mention our reportathon event too.
Yeah.
Folks already have reports. So good. But
right.
Emma, how are we doing on time here?
We have about 4 minutes. So, and I can drop our closeout information at the hour if we need to. So a little bit of time, 4 minutes.
Absolutely. Yes, Carl, that is definitely a report. Anytime you see the aurora, whether it's not visible to the eye and only to cameras, or whether it looks gray to the eye and bright to cameras, or even if you just see a little bit of haze, just let us know, drop us a report, because we do actually go through all those reports and clean up the data. So you can't report wrong. You can always report well. So if you can skip to the slide with our graphic on it a little bit further. We also have tools for telling when the aurora will be coming out. We would love everybody to join us on Saturday, July 8th, 3 to 5 p.m. Eastern for our very first reportathon. We are looking in particular to gather reports from those big March and April storms, but in general as well. I saw the aurora in Iceland 3 years ago, and I'm planning to make my own reports of the 3 sightings I had. Very excited about that. If you want to register, ooh, here comes my thunderstorm. Go to bit.ly/reportaurora. And you can register to join us. We're going to have a lot of fun. We're doing door prizes. It'll just be a great time together. Liz, do you want to, and Hugo, do you want to kind of close us out?
Sure.
Okay.
I would just say thank you to everyone. And if anyone wants to learn more, even if you haven't seen Aurora, you can also join the reportathon and help us check out some of the reports and get to know the community. And yeah, thank you so much for being with us, Hugo. Over to you.
Well, I just want to say a few things quickly for people to, when you see the aurora, it's such a beautiful thing. It's such a magical event that seduces you. Once you see it one time, you want to see it all the time. And also we need everybody's help, because if we help Aurorasaurus by posting what we see, when we do our reports, NASA is gonna get better at their applications and websites and all those things. And in the end, everything is gonna come back to us because they're gonna predict Aurora better, and it's gonna be better for them. It's gonna be better for us. And Aurora is beautiful. If we have a chance to see it, I always tell everybody that there's nothing more beautiful in the world than Northern Lights. And thank you for having me here, and have a good weekend.
Thank you so much,
Thank
Hugo. And I
you.
just wanted to echo our gratitude for your being here as well.
You're welcome.
Thank you to everyone who has been speaking for this project. It's been super enlightening to hear about all these things and beautiful stories. Hugo, your story and your pictures are marvelous. I don't know how you got so good at taking those photos, and I look forward to seeing how wonderful everyone else's photos are when you guys go to the Saturday, July 8th event, right? For everyone online. I'm going to go ahead and close us out on our SciStarter side, just to let you know what's happening up next. But just a brief thank you again for all of you on the Aurorasaurus team. Thank you so much for making the time to be here. We will have a follow-up message, by the way, for everyone who is online with us right now and whoever registered. We will have a follow-up email with a whole ton of things, including these links here, the video for the bottle concept at a museum, and that app recommendation, etc. My Aurorasaurus friends, if you think of anything else that you'd like put into that follow-up, please let me know, and I will send it out tomorrow. So can do that. For anyone who is realizing that SciStarter Live is the best thing ever, because that's probably all of you, you can come to our next one on the 11th of July, because we're taking a break on the 4th of July for Independence Day for the US. So you are more than welcome to join. We're going to be talking about Shark Week and how to safely monitor shark populations as a citizen scientist, community scientist, etc. We also have a forever link if you'd like to use this one to register for any of our events. So you can go to that link or scan this QR code. Our blog has more information if you'd like more, especially on how to get started or how to get how to prepare for any of our events if you would like to prepare in advance. So with all that in mind, in addition to SciStarter Live, we have a sister event process, which I noted on the previous slide, the Do NASA Science Live with NSTA. That is a specific partnership with NASA that we're doing a bunch of events with them over the next 2 years. So if you'd like to go to that one, it's technically not a SciStarter Live event, but it's like a sister event. So you can get information from us here, and you can go to NASA-Live on our SciStarter site to find out more information and learn how to register. Although I believe, Roland also dropped it into the chat for that one. And that one will be about the moon and a bunch of different NASA science projects. So, or NASA science experiments, excuse me. So if you'd like to join us there, that'll be on July 20th at 7 p.m. ET. So happy to see you there. Awesome. All right. All that said, we have a million resources as usual. You're welcome to use them all. You can reach out to us at info@scistarter.org anytime you need, and we'd love to hear your thoughts. So we do have a survey to send out to you at the end of this. So when you close out of here, you'll get that survey, or you'll be sent it as we remove you from the call. Otherwise, thank you all for joining us. It's been lovely. I'm going to go ahead and say goodbye to Facebook and end our recording. That's the word. Awesome. All right. Bye, Facebook. If I can, there it is. And goodbye, live stream.